In this video, we are going to answer two questions on integration. So mixed exercise 11.02 is on integration for A-level pure maths, year 2. Question 1. A. Use a suitable substitution to find the integral of 16x over 1 plus 4x squared dx. B. Given that y is equal to pi over 2 when x equals to 0, solve the differential equation 1 plus 4x all squared dy dx is equal to x over cos squared y. So for A, I need to integrate 16x over 1 plus 4x all squared dx. The appropriate substitution to use here will be to let u equals to 1 plus 4x. If I differentiate u with respect to x, I'm going to get du is equals to 4 dx. But I need to do my substitution for dx in terms of u. So I'm going to make dx the subject here and get 1/4 du is equals to dx. But we also have to substitute for the 16x. So I'll make 4x the subject in this equation, and I'm going to get 4x is equals to u minus 1. The substitution for 16x will be much easier if I multiply 4x by 4 to get 16x. So I have to multiply both sides of this equation by 4. So I'm going to get 16x on the left-hand side and then 4 brackets u minus 1 on the right-hand side. So we can go ahead now and do our substitution, and we're going to get the following. So this will be equals to the integral of 4 brackets u minus 1 over u squared times dx, which becomes 1 over 4 du. This will cancel that, and we're going to get the integral of u minus 1 over u squared du. I can rewrite this as follows. The integral of u over u squared minus 1 over u squared du. And this can be reduced to the integral of 1 over u minus 1 over u squared du. This can also be written as the integral of 1 over u minus u to the power minus 2 du. Now, the integration of 1 over u is ln u, but for this one, the integration will be, I need to add 1 to this and divide, and so I'm going to get 1 over u divided by minus 1, because 1 plus minus 2 plus 1 is minus 1, so I get a negative here. And I'll get my integration constant here. And so the whole of this integration becomes ln u plus because this is negative, and negative becomes positive, 1 over u plus your integration constant. But we have to change the variable to x, and so we're going to get ln 1 plus 4x plus 1 over 1 plus 4x, and then we add our integration constant. And so this is the integration for part A. For B, we need to solve this differential equation here. So we can do that by separating the variables as follows. The integral of cos squared y dy equals to the integral of x over 1 plus 4x all squared dx. We have already integrated this one here, which looks similar to this. So if we multiply both sides of this equation by 16, we can get this side to look exactly like that. In that case, we can use the integration that we've done already in A. So I'm going to multiply both sides of this equation by 16, and I'm going to get 16 cos squared y dy equals to 16x over 1 plus 4x squared dx. And so now we can use the integration that we've done already in A for this part. For the left-hand side, we are going to use a trigonometric identity to change this form into one that can be integrated easily. And the identity that we are going to use is cos 2y is equal to 2 cos squared y minus 1. All I have to do now is make 2 cos squared y the subject, and I'm going to get 2 cos squared y is equal to cos 2y plus 1. Looking at the left-hand side of this equation, I've got 16 cos squared y dy. And so if I multiply both sides of this equation by 8, then I can get 16 cos squared y on the left-hand side. And then I can do my substitution here easily. So I'm going to multiply both sides of this equation by 8. So I'm going to get 16 cos squared y equals to 8 brackets cos 2y plus 1. I can now do my substitution here easily as follows. 8 integral of cos 2y plus 1 dy equals to the integral of 16x over 1 plus 4x all squared dx. We are now ready to integrate. And all we do now is integrate the left-hand side, which is this one, because we already have the integral of this from part A. And so if we integrate this part, we are going to get 8 brackets half sine 2y plus y equals to the integral of this one, which we got from A, and that was ln 1 plus 4x plus 1 over 1 plus 4x. And we just have to add our integration constant c. If we simplify this, we are going to get 4 sine 2y plus 8y equals to ln 1 plus 4x plus 1 over 1 plus 4x plus c. But we know that when x equals to 0, y is equal to pi over 2. So we can do the substitution to get our constant, the value for c. And so if we do that, we are going to get 4 sine pi plus 4 pi is equals to ln 1 plus 1 over 1 plus c. This implies that 4 pi is equals to 1 plus c. And that means c is equals to 4 pi minus 1. So our integration constant is 4 pi minus 1. We can now write our full equation, which will be 4 sine 2y plus 8y is equals to ln 1 plus 4x plus 1 over 1 plus 4x plus our integration constant, which happens to be 4 pi minus 1. And this is the final answer required. Question 2. The diagram, this, shows the graph of f of x equal to 3 to the power x minus 5x plus 2. Find the exact value of the integral of 3 to the power x minus 5x plus 2 with respect to x and between the limits of 0 and 1. Looking at the graph very carefully, you see that intercept on the x-axis here is 1. And so we can integrate between these limits, 0 and 1, without considering negative values, which will fall into this place. So we go ahead and do the integration directly. So we have the integral of 3 to the power x minus 5x plus 2 the x from 0 to 1. For 3 to the power x, we will let y be equal to 3 to the power x. Then I can take logs of both sides. So ln y is equal to ln 3x. But we can rewrite this using one of the laws of logs as follows. ln y will be equal to x ln 3. Again, using some laws of logs, we can write y as e to the power x ln 3. But we know that y is equal to 3 to the power x. It means that we can replace this with 3 to the power x, and we are going to get 3 to the power x is equals to e to the power x ln 3. So we can now replace 3 to the power x with e to the power x ln 3. So let's do that, and we are going to get the integral of e to the power x ln 3 minus 5x plus 2 dx. This is in the form of this, the integral of e to the power kx. And we know how to integrate that. That will be 1 over k e to the power kx. So similarly, we can use this principle here to integrate this one, because in this case, the k is ln 3. So if we integrate that, we are going to get 1 over ln 3 e to the power x ln 3 minus 5 over 2 x squared plus 2x between the limits of 0 and 1. We can now evaluate this by putting 1 and 0 into this and subtracting them, and we are going to get 1 over ln 3 e to the power ln 3 minus 5 over 2 plus 2, all of that, minus. Put 0 into all that, and you're going to get 1 over ln 3 e to the power 0, and the rest will be 0. So we are left with this. We also know that e to the power ln 3 is equal to 3. So the whole of that becomes 3, and therefore we have 3 over ln 3 minus a half, because minus 2.5 plus 2 will be minus a half, minus 1 over ln 3. Again, because e to the power 0 is 1. And this will simplify to 3 over ln 3 minus 1 over ln 3 minus a half. And this will give me 2 over ln 3 minus a half. If we simplify that further, you're going to get 4 minus ln 3 over 2 ln 3. And that is the final answer for question 2.